Here we've got a differential equation. It gives us a second derivative, and it's e to the x. It's a pretty simple one to start with here. So it says, find the solution of this differential equation. And they happen to give us a couple of boundary conditions here. X equals 0, y equals 2. And when x equals 1, y equals e. Those are going to be helpful. So to find the solution, they're actually kind of asking for the original function here, okay? And we see that we have a second derivative, so we're going to have to integrate this twice in order to get back to our original function. The integral of e to the x is e to the x, and you have to add in your constant of integration here. And notice I've taken my derivative and I've make it into a first derivative. Now I'm going to take my first derivative and take it back to the original function by integrating again. Integral of e to the x is again e to the x. Integral of c is cx. Let's see, constant rule there, constant multiple rule, sorry. And then basically, if you kind of think about taking the derivative of cx, the derivative of that is just c. And then don't forget you have another uh, um, constant of integration here, okay? A lot of textbooks might call this C1 and this one C2. I just put a C and a D, okay? Well, here's the answer. It's e to this x plus cx plus d, but we don't know what c and d are. But they did give us two boundary conditions or initial conditions here, which allows us to make x equal 0 here, and y equal 2. And then a little bit of algebra will take you down, and you'll see that d is equal to 1. Then you do it again with the second boundary condition, 1e, right? So make x equal 1 and make y equal e. And you go ahead and you algebra your way down, and you find that c is equal to -1. Not forgetting that d equals 1, which was discovered over here. You can place that in at that location. And so there it is. When d is 1 and c is -1, you have an equation such that when you differentiate it twice, 1, 2, you get this. And not only that, these points are on the original equation. Okay?